Welcome to the session 5 of module 5. In this session we are going to discuss about leech and SMAX. Leech is a low energy adaptive clustering hierarchy. So it is for dense network of nodes reporting to a central sink. Each node can reach sink directly. So that is the concept. So we have several nodes and we have one sink, and each node they will directly send the message to the sink. So what are the nodes that are present? Many nodes that will be grouped into grouped as clusters. Okay, so if consider that 100 nodes are present, so if we divide the nodes randomly, consider like equal nodes for one cluster, like 10 nodes for a single cluster, there will be 10 clusters that are available, and each 10 clusters will have the cluster head. In those 10 nodes, one node will be selected as cluster head, and that cluster head that is responsible to transmit the data to the sink node. So that is the concept of leech, low energy adaptive clustering hierarchy. So here the condition is about 5% of nodes become cluster heads depending on scenario. So what may be the scenario is, so it may be the distance between the sink and the cluster head, or it may be the energy that is present in the particular node. So if the more energy that is present in the particular node, so that will have the more chances to become as cluster head. Or if some other node not at all used as the cluster head, so that can be selected. So different and depending on the scenarios, and that particular, if the cluster head that is dead, so then that particular group or the area we cannot able to sense that. So keeping in that mind, so we are going to give the chances to the all the nodes practically as the responsibility of the cluster head. So the role of the cluster head that is rotated to share the burden. So that is the way what we have discussed now. So cluster heads advertise themselves. Ordinary nodes join cluster head with strongest signal. So in consider 100 nodes are present, and in those 100 nodes, so that means 100 nodes into a single cluster. We have single cluster that consisting of the 100 nodes, only 5 nodes. So that's not mandatory, but approximately 5% of the nodes, that means the 5 nodes that will advertise as are going to become a cluster head. So then what happens is, so the ordinary nodes that are going to join to the cluster head, and in those 5 we need to choose the one cluster head, so that will have the more energy and the less distance. Okay, so depending on the different scenarios, we are going to choose the cluster head. So that cluster head that is responsible to transmit the data to the sink. Okay, so cluster heads organize CDMA code for all member transmissions. TDMA is scheduled to be used within a cluster. In steady state operation, cluster heads collect and aggregate data from all cluster members, ordinary nodes that will send the data. So it is going to collect the data and aggregate the data and report that aggregated data to the sink using the CDMA. So TDMA, that is to accept the data or to communicate the transmission between the ordinary node and the cluster head. CDMA to transmit the data from the cluster head to the sink. So we can see here the leech rounds. So this is a fixed length round. So we have 2 state, setup phase and steady state phase. So in the setup phase we have self election of cluster heads. So that's what cluster heads that will compete for to become a cluster head. cluster, that means the nodes that will compete to become a cluster head. So that is advertisement phase. So the cluster heads that will compete with the CSME, and the cluster setup phase, the members compete with the CSME, and then broadcast schedule. So now it has been set up that cluster head has been chosen, and the time slots that are been allocated for the stations with TDM. And in steady state phase, time slot that will be allocated to the ordinary nodes. In that time slot, ordinary nodes that are going to exchange the data between the cluster head and the nodes. So if the time slot is over, so that means so we have divided the time into 100 slots. Again, the first station that is going to get the time slot after the 100th node. Again, it will get the chance after the 100 time slots. Like that, it's going to keep on repeating. So depending on the fixed length round. Okay. So after the time length or the leech round is over, again we need to choose the another cluster head. So this is about the leech. SMAX. So here we have many radio channels. Super frames of known length, not necessarily in phase, but still time synchronization is required. Goal is to set up the directional links between neighboring nodes. Link is radio channel plus time slot at both sender and receiver. It is free of collision at receivers. Channel picked randomly. Slot is searched greedily until a collision-free slot is found. The receivers will sleep and only wake up in their assigned time slots once per superframe. So in effect, a local construction of a schedule that is going to take place in SMAX. So here SMAX link setup, we have two stations X and Y. So we have a unconnected type 1, type 2, type 3, type 4 messages that are going to be exchanges. So these will be protected by randomized backup. In case 1, node XY both so far unconnected. Node X sends an invitation message. Node A answers telling X that is unconnected to any other node. Node X tells Y to pick slot or frequency for the link. Node Y sends back the link specification. So then the communication that will take place. Second case, X has some neighbors, but Y doesn't have any neighbors. Node X will construct link specification and instruct Y to use it. So in which time slot it is going to transmit. So why? Because since Y is unconnected or unattached. Third case, X got no neighbors, Y has neighbors. So then Y picks link specification. Now the case 4, both nodes already have links. Nodes exchange their schedules and pick free slots or frequencies in mutual agreement. So this is how the SMAX link setup that is going to take place depending on the different cases. That is about this particular session, and I obtained the content from Protocols and Architecture for Wireless Sensor Networks textbook written by Holger Karl and Andreas Willing. And thank you.